Alrighty, testing mic 1 2. Hope you guys can actually hear it. So Kon-Kazu lads, this is your electro student Vtuber, Natsuki Kazuya. So okay, tonight we're just going to be doing some pretty simple topics for this month's study stream. It was supposed to be last week, but suddenly my Wi-Fi wasn't actually able to do it. Wasn't able to do anything about my Wi-Fi. It suddenly had some sort of disruption at my area. But now we're back, and suddenly the Wi-Fi has gotten much better, surprisingly. So it's okay. At least I could try and do streams quite frequently from now on, if I could find the time, that is. So enough about that. So tonight we are going to study a bit of physics. So what is physics exactly? Physics is kind of like the subject where you involve sciences as well as calculation. That is quite the basics of physics. So okay, first of all, what you need to learn about physics, write down P-Y-S-C-S, physics. You guys could actually see that. Yeah, I hope you guys can actually see that. So physics is kind of like the study of the physical world, the world we live in, before the start of the creation of cells, even before the start of the creation of chemicals. So we gotta deal with the physical theories, and these physical theories we express them in the form of maths. So that is the basic concept trying to learn physics. So physics, we also need to conceptualize according to topic. So, and then you also need to understand the basic laws plus the quantities of this study of science. So the basics of physics that you need to know is just about length, mass, and also time. So those are the basic things that you guys have to learn. But I think you guys would actually know what all of these units are. So if you do length, you just measure a straight line, for example. If mass, you try and weigh out an object, like for example 1 kilogram, and as of time, we just try and calculate what time is it. So 3:13, but 12, yeah. So that is just the basic concept of physics. So we'll erase this. Right now I'm actually using Krita, not gonna go with online software for now, considering that I'm just gonna use whatever software I have at the moment. So okay. So you guys have to remember that physics this out, take this out. Try and should I reduce the size? That is to zoom in out. Okay. This one? Yeah, is this one? Alright. So the first thing that you guys need to understand is the basic. I erased it again. Okay. Basic, dang it, units. So now we've established the basic quantities, which is length. Then there's mass. Then there's time. So length, the unit of length can be measured in the form of meters, and mass would be in the form of kilograms, and time would be in the form of seconds, for example. So these are just the examples of these units. So wait, meters, kilograms, and also this one is in seconds. Let me know if you guys can't actually see what I'm drawing right now. Mine, go up, out, 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 out. A bit lower, 8. So next, you guys should also need to learn about is the side there, prefixes. So here are, so the prefixes. Prefixes are basically like the same units just now, but they are either smaller or bigger. So either smaller or bigger, and you guys actually have to change them. You guys can actually differentiate them in how much powers of 10 used. So powers of 10. Why can't I draw this? So powers of 10. So let's just try and do something like small an arrow here. So we'll start with small to large. So here is the basic. There's a lot of prefixes that you guys need to know. You guys that exist, but they're like 1, 2, 3, 6, and 9. Yeah, 9. So I'll list it down. It would be, I'll start off with pico, the nano, micro. Hello Kazuya, hello Ryu Trimudika, welcome to my stream. Hope we could have a chill session right now. So where was I? This is micro. This is milli. And then we go to centi. And then we go to, okay, so this is centi. So this is, and then we go back to the normal well, I'm just labeling this because this doesn't have a prefix. Just so you guys know that. But anyways, we'll start with eco. The short form we're going to put in the units is P. Nano is N. Micro and milli are different. So micro, you have to do something like a mu, something like an odd looking M, like that. Then there's the milli, which is just a simple M. Centi would be C, and normal doesn't have a like I said, doesn't have a prefix. So we'll just proceed with deca, and then there's kilo, there's mega, and then there is giga. There's a lot more than just giga, but there's also something like like there's peta, tera, peta, and exa. Like, so deca would be DA, kilo would be K, mega would be M, giga would be G. Since we already have micro and milli, things are just small letters. Micro is kind of like a smaller version. So mega, instead we use a capital M so that we can represent how big the number actually is. So pico, so that is the basic prefix. And then pico would be, we should also consider the basic prefix as well, which is, oopsie, that I dropped my pop filter. You should also consider see the powers. So pico would be 12, nano would be 10 power minus 9, micro 10 power minus 6, milli 10 power minus 3, centi 10 power minus 2. Normal, we'll just consider this as 10 power 0. That means we don't have any kind of prefix in there. And then there's deca, so deca would be times 10, kilo would be times 3, so mega would be 10 times power 6, and giga would be 10 power 9. And that would be all for prefixes. So if we want to actually put this in some form of unit, for example, the units, if we want something like length, so for example, meter. So meters, if you want to go a bit smaller, if you want to go smaller, then just use something like milli or centi. So like this is like the general kind of units used for the ones like you see in the ruler, for example. They're like centis, and then just drop down, split into 10 parts. So those 10 parts are actually measured in millimeters, while from the first part until the 10th part it would be measured in centimeters, but you can also measure it in millimeters as well. There's also, if you want to put like mass, Like for example, if you want to weigh something, it would usually be measured in the form of kilograms. And kilograms, yeah. So for example, if you're measuring your own weight inside on a weighing scale, that's where you know you would usually be around in the unit of kilograms. That is for mass. My mic is too low. Hold on a second. Okay. So that is the basics for you to understand about the units that we might be using for our calculations later on the stream. So okay, and if you want to try and convert this from centimeter to millimeter, for example, we could try and use the factor label method. This method is used if you don't want to actually use the calculator. The calculator itself, you don't really have a specific prefix for you to use inside the calculator, or you just use it, remember the prefix and just use it inside your calculation. But by using the factor label method, we use it to try and how should we do that again? Like for example, if you want to convert centimeters to millimeters, the method that we could use is by putting out, for example, 12 centimeters. So 12 centimeters, we convert that into use the prefix that we want to change, put it on top. So we want to change from centi to milli, so we'll do 10 to the power of minus 3. This is millimeter. To be honest, it should be like 1 times 10 to the power of minus 3, but we're just making this for simplification. And then we do 10 times 10 to the power of 2 centimeters, where we have to cancel these two together. And then we just use this to actually, and then we just solve them by just using basic calculation. So for example, right here, it would be 12 times 10 to the power of minus 1 millimeters, because we're going for a smaller number. Oh wait, really? Hold on. Wait, we're going for a smaller number. So 3 minus 2, 12 times 10 to the power of minus 1, 1 over 10. Could it be 1.2 millimeters? Because I believe... Hold on. I think we have something wrong here. If you guys can't actually try and use this method, just try and calculate normally with the calculator. So 110 minus 3, 110 minus 2 should be 1.2. Okay. So there is something wrong here. Second, factor label method. So 1.10 times 10 power negative 3 times 10 power minus 2. No. To be fair, you want to convert them back to Hold on, we'll try and erase that. So centimeters, because we're dividing them, right? So centimeters to millimeters. Usually we multiply them by 10. So okay, so I didn't get that one right. So that means we should use it 10 power 3 millimeter, 10 power 2 millimeter. No, centimeters. Because we're going to go to a smaller number. So this one should be 3. 3 minus 2 would be 1. So 12 times 10, 120 millimeters. That is how it would actually, that is how it would work. So yeah, that is basically the factor label method. But okay, look, I think we should try and do this again. I don't think I'm actually going to be quite satisfied with the result. So okay, factor label method. So we'll do a division. 1 times 10 to the power of minus 3. 1 times 10 to the power of minus 2. Millimeters to centimeters. It would still be minus 1, which is actually wrong. So okay. Centimeters, and then there's millimeters. Since we should be going for a smaller number, you know what? Let's just go in and search. Hehehe. So yes, it should be 120 millimeters, right? There should be a way, because this is actually an error. What is going on? Okay, so 12 centimeters. If you want to convert from milli to centi, no, centi to milli. 10 minus 3, no, 10 minus 2, 10 minus 3. So 10 minus 2, and then 10 to the power of minus 3 millimeters. Oh, there's gotta be something wrong here. Definitely. Gonna be quite the hard part here. No, but this thing should be easy. Okay, I think I actually did messed up quite badly here. Okay, got that. Okay. Oh, alright. So 1 centimeter would be equals to 10 millimeters. So we should do it like 10, 3, 10, 2, 10. So this would be 10, 3 millimeters, 10, 2 centimeters. Cross this out, this would be 10 to the power of 1. So 12 times 10 would be 120 millimeters. So that is how you do it. So to recap, because from 10 to 2, change it to 10 minus 3, so that would be a difference of 10. So 10, if you want to go to smaller, you need to multiply it. So you should multiply it like this, and you'll get 120. So there it goes. Do it. Let's just erase all of this. Come on, come on, come on, come on. Okay, there we go. Well, that's done. Oh, what else? What else should we do? Okay. Now once we've now recognized how we could deal with the trigonometric stuff. No, the units just now. So we've kind of clarified that. Maybe we could try and do one more exercise. For example, from centimeters to kilometers. So 10 minus 2, 10, 3. So that is 10, 2, and then there's 10, 3. So we'll do, like, for example, 15 centimeters. Convert them to kilometers. So it's 1 times 10, if you remember the prefix just now. 1 times 10 power 3 kilometers. 1 times 10 to the power minus 2 centimeters. So 3 minus negative 2. This would be 5. That would be 5. So get your calculators. 15, 10, 15, 10, 5. So the answer would be, just want to do it simply, 15 times 10 power 5, or 1,500,000. That is how you usually do it. So, and you guys should also know that these prefixes, so wait a second, I think I've done some mistake of some kind. Okay, no. Yeah, I think I've done a mistake of some kind. That is actually brutally wrong. That is quite wrong. Okay, so if we want to try, hold on, let me check my textbook. We actually do have a textbook here. Because we're just going to study, so third unit convergence. Unit convergence, so 15 centimeters, and then we do that by trying to establish that we need to convert it to, oh okay, so 1 centimeter. That means, and then this would be 10 minus 2 cm equals to 10 3 km. I don't think this is the right way of doing this. Gotta be a way here somewhere. Because we could convert these prefixes quickly. Not really 1 times 10 power 5, it should be 1 times 10 negative 5. Negative 5 kilometers. This would be negative 5. 15 times 10 to the power negative 5 would be 1.5 times 10 power minus 4 kilometers. So yeah, I think that is how you actually convert the units. So okay, enough about that. I think try and come back later. So, okay. So good. I think we can clarify the prefixes later. So I think we should try and do something about trigonometry then. So understanding trigonometry in physics is actually quite important, where you need to learn a lot about the vectors as well. Let me grab my line tool, do something. Do a straight line here, and we'll do straight line here. So we have a Cartesian plane, and then we have this. We have a line around here, and we have a straight line parallel to this line right here. So you need to understand your trigonometry. So this is the right angle, that, and this is that. So you need to understand your sines and also your cosines. So for example, so if you want to simply know what cosine actually is, so this is your hypotenuse, and this is your angle. So the line that actually corresponds with the hypotenuse and the angle is actually the cosine. So like for example, we'll do another triangle. Nope, no mirroring here. So one straight down, one to the left, one above. Okay, it's not really that perfect, but you get what I mean. So we'll do that. Do this. So if you want to get a cosine, like for example, this is 60. Hypotenuse. This is for example 60 degrees. So if you want to go to the side of the triangle that has the angle, side has angle. So like for example, if the hypotenuse for example is 9, so 9 would be, if you want to go to this angle, it would be 9 cos 60. If you want to go to this, so this is the side that has the angle. If the side that doesn't have the angle, this would be sine. So this one would be 9 sine 60. And that is how you deal with that is how you actually deal with the angle, with the trigonometry. Just remember that if you're dealing with the side that has the side here with this side and an angle between, this side is the cosine of the hypotenuse. So the side that is opposite that, this would be the sine. This is the cosine, this is the sine. So that is quite the simple trigonometry. Take that out. So erase that. Go for that. Go like this. So okay, in trigonometry, you guys should also know that this is the part where you should also try and cover in vectors for a short while. So, hold on a second. Let me try and grab a question that we could do. Okay, so for example, you should also learn about displacement. So let's just say that we have a line here. Line here and line here. Oops, okay. So from this direction to this direction, from here to here is considered displacement, while displacement, it means that you're moving from one position to another position. So this is gonna be, for example, let's say 5 meters. So from this position, you're, for example, this is up, this is right, this is down, this is left. So you're moving from one direction to another. So you're moving from this point to this point, so this is like 5 meters to the right. So that is how you deal with the displacement. So that, oh yeah, right. We'll do that again. Sorry about that. Okay. Distance is actually the point traveled from here, from one point to another point. So 5 meters, we only consider this as 5 meters. So this will be counted as a scalar quantity, which is the quantity that only has the magnitude. So the magnitude is 5 meters. Displacement is 5 meter is as if you have magnitude and direction. That is a vector quantity. So you go from one direction from this position here to this position here. That means this will be, for example, 5 meters to the right. So that is the direction. So okay, there we go. There's also other kinds of scalar and vector. So if you do scalar, vector, so for example, scalar would be distance, mass, and also time, and also speed. Vector quantities include velocity, force, what's next? Like velocity, force. We'll put in something like, well, if you want to say gravity is part of the force as well. Like that is how the basics should be put out, like that. Okay, velocity, force, and other one. Frequency is scalar, or scalar. Current. Current is a vector quantity, because you have the direction of current going from somewhere to somewhere. So that is where the current would be. So that is how you deal with the scalar and vector quantities. Let's try and go back. But yeah, so today we're just going to learn about Tonight we're just going to study about forces. So hold on, let's see. Next would be, so we're going to learn a lot about forces. Da, 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 da. So we'll just do some kind of mind map for you guys to actually understand what it is. So forces is part of Newton's second law, which is F equals to ma. Second law. And then it is, as we clarified just now, it's a vector quantity. And then next, it is also that it has acceleration from the unit here. And what is next? What is next about forces? We should also do something that is related to the free body diagram. We are going to involve a lot of free body diagrams inside forces. So let me just go back. Just go and grab. Let me grab my book. Oh yeah, there's also times when if for example object is not moving, or constant velocity F could be equals to 0 because the acceleration is 0. So that is when the object doesn't have some sort of applied force to it. It's just moving in the constant state of motion. So yes, that's how you deal with that. There is also friction force. Friction forces, where the force is actually moving at the opposite of the applied force. So for example, we do something like this. Force is moving here, so we label this as a small force, small f. So this thing is actually when there is a rough surface. For example, if it's a smooth surface, then this will be labeled as frictionless. So there's a lot of types of forces here. Types of friction force. This would be static or kinetic. So from static to kinetic, static means that the friction to hold down the block in its constant, in its state of motion right now. Or is it? No, that's not right. the let me just try that. So kinetic forces doesn't really hold down the object, but just make sure that the object stays in place. So hold on, let me get the Newton's second law, the friction stuff. Okay. Wait, let me see. Because usually friction force is like when the object is actually at a state of equilibrium, while kinetic is actually at the state of movement. So this is F equals to 0, F equals to ma. So that is going to be friction force. So okay, that is going to be the friction force as of now. So what's next? Maybe this might just be quite a short stream tonight because there's not much topics to actually cover about. Maybe I could try and put in some exercises later on the stream. But okay. Erase that, erase that. Go there, go there, there, there. Alright, we got that. Let me just get a sip of water. Got that. So okay, next what we gotta learn about is the free body diagrams. Free body diagram. So free body diagram is a diagram for you guys to actually get the object and label all of the forces that is applied to the object. So all of these are just more towards external kind of forces. So like for example, here is an object. So if it's at a surface, okay, it should be in the ground, but never mind. This would be this weight. So the contact of the surface, this would be the normal. So that we could balance the forces out so that it wouldn't be moving. And for example, we have a force here. So the force is applied towards the right direction, towards the right. Well, there's also a frictional force here. If there is friction, So this would be an F. This would be a small F right here. Just so that to go down there like that. So that it would be the free body diagram. So okay, what else? I guess that's it, maybe. So okay, I guess that is all for my entire stream. So I guess that's pretty much it. Okay, so I believe we can actually end this quite early tonight, so it's okay. So thank you guys for coming to my stream, Otsukazu, and I believe I can actually see you. I'll see you all in next stream. So next stream would be Asaro Corsa, maybe. Yeah, Asaro Corsa. So hope you all can join my next stream on Saturday. So thank you. Bye bye. Otsukazu.